In this lesson, we're going to discuss the concept of flow, the flow of water, and this is in the context of water hydraulics. This is part of a series of 5 videos where we discuss pressure, flow, velocity, and friction loss, and then we're going to learn how to read a friction loss chart, which is kind of important to understand all of these concepts and put it into practice and how we're going to be dealing with irrigation on a day-to-day basis. So the definition of flow, it's the measurement of the volume of water that passes over a specific point in a given period of time. In the US, we're going to measure this as gallons per minute, right? In other countries, for instance, for the metric system, that's going to be in liters per minute. But we're also going to be talking in other places, especially with the drip irrigation, that's going to be gallons per hour, right? Drip is a very low flow system, so we'll deal in gallons per hour and not gallons per minute. I'm going to give you the conversion factors of all of this and how to convert it at the end of this lesson, plus the conversion factors are going to be in the PDF download that you'll get from the first lesson in this course. But the deal with flow is it's a little tricky and it confuses people because it's generally not a set value in an irrigation system. It can vary as the pressure varies, right? This is why we try to constrain the pressure as best we can by using pressure reducing valves if the pressure is too high or whatever. But the problem is in a city water system, and I use this kind of concept a lot, city water, and that basically means that you have a supplier, a central supplier or purveyor of water that has water lines out in the streets that delivers water to all of the homes and businesses, and we pay them for that water, right? And so where I'm at, we get a water meter and we're paying by the gallon for our water. And so what we're constrained by is the size of that water meter and the size of the tubing that connects the water meter to the main water line. Here we have 4-inch water pipes out underneath the street, and then we connect to that by copper tubing to a brass and copper water meter. And so usually for a residential system, that meter is probably going to be either 5/8 inch or 3/4 inch. And probably what you're going to be dealing with there is somewhere between 15 to 18 gallons per minute. And because pressure fluctuates, right, in these systems, depending on if you're in a neighborhood and the time of day that you're measuring it, these pressures can fluctuate by 20 or 30% because different number of people are home. Maybe they're doing dishes at a certain time of day. Maybe you're running at the time in the morning when everybody's taking a shower or a bath or whatever. So we always suggest that you design your systems at 80% of what the maximum is for that size of meter and that size of tubing that connects the meter to the main water line. Now also, as we design our systems, how we control the flow is by the number of heads that we put on a zone and the size of the nozzle that we put in the head, right? And so as you get different pressures, you're going to get a different amount of water that comes through there. As pressure goes up, flow goes up. So as we look at this performance chart for a sprinkler head here, you can see along the left side the PSI. As you look out across the chart, you see that for different nozzle sizes, you're going to get different flow rates. So this is all things that you need to know so that you're not over designing or not putting too many heads per zone on there, right? So the relationship is, we talk about this in other videos, but as pressure goes up, flow goes up, right? Because there's more energy pushing the water through the pipe. And as more water flows through it, it necessarily has to go faster, and that's called velocity. And the faster that water moves through the pipe, the more friction loss that you're going to encounter, meaning that there's friction as the water is passing through the pipe. It has a little turbulence on the outside of this. And I know as you look down inside a piece of PVC or polyethylene, it looks so smooth, you would think there's no friction there, but there's definitely friction and it's measurable. And you'll see this in the lesson on reading a friction loss chart, that The higher the pressure equals the higher the flow equals the faster the velocity and the higher the friction loss. And so sometimes we think, well, more pressure is good, more pressure is better, and that's true to a certain point. You can push more water out of these heads with more pressure, but there's a point of diminishing returns. And we'll see that on the chart to where there's a recommended limit that you don't try to get more than X amount of water through a certain size of pipe. If you do, then the friction loss goes exponential and it scrubs all of the extra pressure that you thought you were putting in there. It just scrubs it away and you lose it. So there's a point of diminishing returns. So this causes a problem in thinking about it for the irrigation technician, right? I've seen a number of beginner technicians who go out and they encounter a zone and they look at it, none of the heads are really doing well. It's just barely spitting out a little bit of water. And the first thing they say is, we don't have enough pressure. That may be true, and technically it is true, but it may not necessarily be the situation that the valve is failing or there's a leak. There may be too many heads on the zone. And if you've ever seen systems that are designed by somebody who didn't know what they were doing, and they thought, gosh, I can just put 10, 12, 20 heads on this zone, well, that don't work, right? Unless you know what your anticipated like pressure and flow is, you have to design your system around those numbers because you just can't keep adding heads. And what happens is, let's say the system was designed properly, but then over the years, the landscape changes, somebody adds some more grass out at the back of their property where there wasn't, irrigated grass before. And now they say, hey, Mike, why don't you come over here and install me 3 new heads in the back that takes care of my extra grass that I've installed there. Well, if I just go out there and I don't ask any questions or I don't do any calculations and I just add 3 more heads and then I turn the zone on and it's womp, 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 and you're not getting any pressure out of that, it means that I've over demanded the flow. It doesn't mean that I don't have enough pressure. Technically, it's true, but what I've done is over demanded the flow, and now I've left the calculations, the constraints of those calculations as to how much flow I can expect out of that zone, right? And that's the reason that we have different zones on an irrigation system is, I don't know if ever there's enough water pressure and enough flow on a residential system to push all of the heads that you would install around the entire property. That's why we have different zones. Like, here typically we have 80 to 90 PSI in the system, and we're constructing our zones with 1-inch PVC down to 3/4-inch PVC. So basically what you can get is 6 rotors or maybe 8 or 9 sprays depending on the size of nozzle that you put on there, right? So it's the number of heads plus the size of the nozzle that you put in the heads. So that's how we constrain that, and don't always just jump to the assumption that there's not enough pressure. We need more pressure. Well, look and count the number of heads, look at the size of the nozzles, and then go to the performance chart and look and add up and say, oh gosh. And I can't tell, the reason I'm talking about this is the number of times I've had to correct zones where somebody's just put too many heads on it, right? And so once you calculate it up and go, gosh, they're trying to get 25 gallons per minute out of a system that cannot deliver any more than 18 gallons per minute. So that's just how you think about this, and I'm trying to give some context to flow because it's a little bit of the most tricky concept in it all. So now let's talk about the conversion factors, okay? I teach all of the courses in U.S. imperial measurements, right? That's the country I live in. I didn't ask to be born here, just like you didn't ask to be born in whatever country you were in. So please don't be angry with me. Stop with the comments, scorching me in the comments, leaving 1-star reviews because I'm not teaching in metric. Look, there's just not enough time in these videos, right? 10 years ago when I started creating videos and I started making these courses, the common wisdom was that you had about 7 minutes of attention span. And now in 2025, it's 4 minutes of attention span. And I can prove that in YouTube analytics. You can see about 4 or 5 minutes, boom, the watch time just drops off like a rock because just its attention span. It's not our fault. I mean, it's the media and everything else that's doing this to us. So what I'm trying to do is make this as quickly as I can, and I'm going to give you the conversion on all these different factors, PSI to bar, gallons per minute to liters per minute. So let's go ahead and talk about that, right? The conversion from gallons per minute to liters per minute is this. 1 GPM equals 3.78541 liters per minute, which means if you're running 10 gallons per minute, that is 37.8541 liters per minute. Now let me complicate it a little bit, that if you're in the UK, a gallon there is not the same size as a US gallon. So here's the conversion for that. In the UK, let's say 1 US gallon per minute equals 0.832674 UK gallons per minute. Or if you're running 10 US gallons per minute, that equals 8.32674 UK gallon per minute. Now you don't have to calculate to 5 digits after the decimal place. Typically 2 digits is about as precise as you'll ever need to be, and a lot of times it's just 1 digit after the decimal place is more, precision than you really need to make here, just to calculate up the number of, the amount of flow per zone. But please go to the first lesson in this course and download the PDF and make sure that you have all of these conversion charts with you. As we go back through and we're re-recording all of the 200 plus videos in our school, I'm trying to include the metric calculation over here on the right side of the screen wherever possible. But when we get into reading friction loss charts and all of that, it just gets so confusing. There's so many numbers. I can't teach in both things at once. So please use the conversion chart and always keep it beside you. Print it off and leave it beside your computer there. So if I say 22 gallons per minute, look over and see what that converts to, so that you can start impressing these numbers in your mind and not always having to use a conversion chart. Because if you're in Europe and you're dealing with bar and liters per hour, after a while you're going to get to know and understand these values in your head just like I do in the US. So that's why I've provided all of these conversions for you. Just please know that I just can't include all of this in a single video, or it'd be a 30-minute video and nobody would watch it. Nobody would get to the end of it.